CO2, H2O and CH4 are A. Bent, linear and tetrahedral. Option B. Bent, tetrahedral and linear. Option C. Linear, bent and tetrahedral. D. Tetrahedral, linear and bent. So this question pretty much is asking us to state the shapes of these molecules. So the first one is CO2. The structure of CO2 now is giving us a carbon with two double bonds to an oxygen. That of H2O is giving us oxygen bonded to two hydrogen atoms, and that of CH4 is giving us a central carbon atom with four hydrogen atoms. So this shape, this is bent, this is tetrahedral. So the shapes of molecules are determined by their lone pairs and electron pairs, yeah. But we won't be going into that in this video. So for now, just stick with this. So the options that match what we just did as linear, bent and tetrahedral, so that's option C. So that's the correct option. You can let me know if there is need to make a separate video on how shapes of molecules are obtained. Just let me know in the comments section. So question 36. Which of the following shows a reaction is in equilibrium? We have delta G equals less than 0. Option B, delta G equals delta H minus T delta S. Option C, delta G greater than 0. Option D, delta G equals 0. So delta G represents the free energy or energy available in a system. So depending on the value, one can tell if a reaction would be spontaneous, non-spontaneous, or in equilibrium. So when delta G is less than 0, this signifies a spontaneous reaction. And spontaneous reaction now means that the reaction will be able to proceed on its own without any external influence. Example now would be evaporation. So when delta G is greater than 0, this means the reaction will be non-spontaneous. This means it would have to require external effects that it can't happen on its own. So when delta G equals 0, it means that the reaction is in equilibrium. So this equation here just gives the relationship between delta G with enthalpy, which is delta H, temperature and entropy. So the correct option is option D. Moving on, question 37. Question 37 says ethene reacts with hydrogen bromide to give A. CH2Br2, B. CH3CH2Br, C. C2H2Br2, option D. CHBr3. So first off, let's draw the structure of ethene. So we have two carbon to react with hydrogen bromide. Ethene happens to be an alkene, and alkene are known to partake in addition reactions. So basically, whenever an alkene partake in an addition reaction, the double bond is converted into converted to a single bond. So what happens is the hydrogen attacks it and form a bond with this carbon. The bromine also happens to form a bond with this carbon. So what we actually have is this carbon, the two founding or initial hydrogen, then the new hydrogen. Sorry, this is what this is. So this hydrogen from the hydrogen bromide that attaches with this carbon is represented here. Now the double bond has been reduced to a single bond. So this carbon and the two hydrogen, we have hydrogen, then the bromine. So if we were to simplify this, CH3, CH3, CH2Br. So the compound option that matches what we just did now is option B, and that's the correct option. So question 38. Question 38 says the solution that will conduct the highest amount of electricity is A, 0.5 m of HCl, B, 2.0 m of HCl, C, 0.5 m of ethanoic acid, and D, 2 molar of ethanoic acid. So we consider we have two types of acids here. Generally, when it comes to conductivity, it's dependent on two factors. So we have concentration and type of ions. So the relationship of concentration with conductivity is a proportional one. So as concentration increases, the conductivity also increases. So this means that 2.2 molar is greater than 0.5 molar. Automatically, we can tell that our option now is going to be between option B and option D. So when it comes to types of ions now, we have HCl, that's the hydrochloric acid, and ethanoic acid, which is CH3C. So HCl is a strong acid and CH3CH is a weak acid. So what this means is HCl being a strong acid would ionize completely, thus it would form ions 100% when dissolved in water. So this means there's going to be much ions compared to weak acid that would not ionize completely in water. So this means that when it comes to types of ion, HCl would conduct more electricity than ethanoic acid, and when it comes to concentration, the higher the concentration, the higher the conductivity. So we have 2 mole per dm cube and HCl. So the option that matches that is option B, and that's the correct option. Moving on, we have question 39, which says substances employed as drying agents are usually A, amphoteric, B, hygroscopic, C, efflorescent, and D, acidic. So let's look at the meaning of these terms individually. So amphoteric, you must have probably seen it as amphoteric oxide. So amphoteric pretty much means something is able to act as an acid and or a base. It usually comes in the form of amphoteric oxides. So amphoteric oxides are those oxides that are able to act as an acid or a base. So if they were reacting with an acid, they would act as a base, and if they were reacting with a base, they would act as an acid. So we know that that does not match what we are dealing with. So before even proceeding further, what exactly are drying agents? So from the word drying agents, we can that it has to do with what? Removing water molecules from compounds. So amphoteric, there's no relationship with amphoteric and what drying agent and drying in general. Let's see that of acidic. So acidic, an acid now is pretty much any substance that would react with a base to form salt and water. So rather than even removing the water, you can see that same with amphoteric, there is no relationship with it being acidic and actually removing water molecule. So the next option, option C, which is efflorescent. Efflorescent now refers to compounds or substance that loses their water of crystallization when exposed. So efflorescent compounds would actually lose water. So they lose water when exposed. So we are looking for a compound to be a drying agent now. It has to be able to absorb water from the compound. So it's the opposite with efflorescent, because efflorescent is actually losing water, while we are looking for a compound that will absorb water. So you can tell that this is also not the answer rather. So option B, which is hygroscopic. So hygroscopic compounds are those compounds that will absorb water when exposed. So this matches our criteria. So for a drying agent to be able to remove water molecules from a compound, it needs to be able to absorb water from that compound. So the correct option is option B. So, and finally, the last question for the 2019 chemistry JAMB. Question 40. Which of the following is found in cotton? A. Starch. B. Cellulose. C. Fat. And D. Oil. So this is one of those questions where you should spend nothing less than 3 seconds, 5 seconds at most in answering. So the correct option is actually option B. So this brings us to the end of the JAMB 2019. Yeah, this brings us to the end of the JAMB 2019 chemistry questions. So I would be releasing the videos of the 2020 as soon as possible. So kindly stay tuned, and also do let me know how this year has been. That's the 2019 chemistry task question, how it has been. If there are any comments, questions, suggestions, do let me know in the comment sections. So until then, do take care of yourself. Bye.